Right, okay, so this is the Engineering Maths Year 1 Complex Numbers questions. Okay, and this will help you with your revision for your exams. So 1A, what you've got to remember here, j is the square root minus 1. J squared is therefore the square root of minus 1 squared, so it's actually minus 1. J cubed, so that's j squared times j, which is minus 1 times j, which is minus j. And then j to the 4 is going to be j cubed times j, so it's minus j times j, which is minus j squared. So it's minus minus 1, so it's plus 1. And then j5 is, and so every time we can get a j4, that's just 1. So j4 is therefore, j4 is 1. So j5, which is j4 times j, well j4 is 1, so that's j, and then the pattern repeats. Okay, so that's the square root minus 1. And if you look there, it's back to the beginning again. So it goes, you can think of it going around here. You can have j to j squared to j cubed to j4, and then it goes back to j again. Okay, so that is also, that's going to be, each of these as we times by j. So that is actually j, that's also j to the 5. Okay, and j to the 9. Because the j to the 4 is always 1. So this is going to be j6, j10, etc. This is going to be j7, j11, etc. You can add on, this is going to be j8, j12, etc. You can add on multiples of 4. Oh, so that page has suddenly got really full. Let's see if I can do this quickly. So 1a, so j squared is minus 1. I've got that one up there. J to the 4 is plus 1. So I've done that one, I've done that one. J to the 7. J to the 7 is the same as j cubed, which is minus j. I'll just highlight some of these. That's j. J squared is minus 1. J cubed is minus j. J to the 4th is 1. And then we go round again. So j squared is minus 1. The next answer is 1. And the next answer is minus j. Right, so that's that one done. Right, j17 is j16 times j. So that is 1 times j, which is j. J to any multiple of 4, and 16 is 4 times 4, is automatically 1. So that's why that's 1 times j. Okay, so there's another answer there. Done that one. J to the 1, 2, 3. So that's j to the 120 times j cubed. J to 120 is 1 times j cubed, and j cubed is minus j. So that's our next answer there. Right, j to the minus 2. Now, what the way to do this, you can think j to the 4 is 1. So it's going to be j to the 4 times j to the minus 2, because we're allowed to multiply by j to the 4. So that's j to the plus 2, which is minus 1. Another one done. Worried about running out of room here. I'll come over this side. The next one, j to the minus 7 is going to be j to the 8 times j to the minus 7, because j to the 8 is 1. So this is going to be j to the power 1, which is j. So I've done that one there. Next one, j to the minus 17. So we can say that's j to the 20 times j to the minus 17, which is j cubed. Because j20 is 1. So j cubed is minus j. That's the next one done. I've got one more to do. Fit it in here. J to the minus 123. So that's going to be j to the 124 times j to the minus 123. Because 124 is a multiple of 4. And every multiple of 4, j to every multiple of 4 is 1. So this is going to be j by itself. There are other ways of working it out, but this is the way that I've decided to do it today. So I've just put some circles on these because this has got very messy. An answer there. An answer there. Answer there, maybe? Didn't like that one. Nope, I didn't like that one either. That was better. I want some nice ovals around these. If possible. Right, that's a bit messy, but anyway, let's move on. Express the following using j. The square root of minus 4. So this is equals to the square root of 4 times minus 1. The square root of 4 is 2, and then it's root minus 1. And the square root of minus 1 is j, so that's 2j. The square root of minus 25. This is the square root of 25 times minus 1, which is 5 root minus 1, which is 5j. The next one, the square root of minus 121. So it's the square root of 121 times minus 1, which is 11 root minus 1. So that's 11j. The square root of minus a squared. So it's the square root of a squared times minus 1, which is a root minus 1, which is aj. And then the last one, the square root of minus 9x squared. So it's the square root of 9x squared times minus 1. And that's 3x times the square root of minus 1, which is 3xj. Answer, 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 answer. Right, next one. Gosh, I hope I've left enough room here. If z1 is 3 plus 4j, z2 is 2 minus 5j. Express each of the following in the form a plus bj, where a and b are real numbers. Standard form, Cartesian form. Right, z1 plus z2. Let's just highlight these so that I can see them, z1 and z2. So if we do the reals, so this is going to be 3 plus 4j plus 2 minus 5j. Do the reals first of all. 3 plus 2 is 5. And then 4j minus 5j is minus j. The second one is 3 plus 4j minus 2 minus 5j. So the reals are 3 minus 2, which is 1. And the imaginary is 4j minus 5j, minus there. So it's 4j plus 5j, so that's going to be plus 9j. 2z1 plus 1, so that's 2 times 3 plus 4j plus 1. So that the reals are 2 times 3 plus 1, which is 6 plus 1, which is 7. And then 2 times 4j is 8j. Next one, 3z2 minus 2. So it's 2 minus 5j minus 2. So the reals of 3 times 2, which is 6, minus 2, which is 4. And then the imaginary, 3 times minus 5j, minus 15j. And then the next one, z1 times z2. So we'll put this in a grid like so. And we've got z1, 3 plus 4j Z2, 2 minus 5j. 3 times 2 is 6. 3 times minus 5j minus 15j. 4j times 2 is 8j. And 4j times minus 5j is minus 20j squared. And then j squared is minus 1, so this is actually plus 20. So our answer is, the reals are 6. Oh, that's supposed to be highlighted. The reals are 6 plus 20, which is 26. And the imaginaries are 8 minus 15, which is minus 7j. Let's get some answers. There's one answer, there's another, and another. Right, F. Got 2z1 plus 1. Gosh, have I got that up there? Yes, I have. 2z1 plus 1 is here, look. So there, it's the answer there. 3z2 minus 2 is the answer there. So they need multiplying together. And 2z1 plus 1 is 7 with 8j. And 3, and that is 4 minus 15j. So that's the answers to part C and D. So it's 28. 7 times 15 is 105. 8 fours are 32. 15 times 8 is 120. So it's minus 120j squared, which is actually plus 120. So our answer is 28 plus 120 for the reals, 148, and 32, do this on a calculator, minus 105 for the imaginaries, minus 73j. Okay, complex conjugates next. Z1 conjugate is 3 minus 4j. Basically, you change the sign here. The sign there, that would do. And so Z2 conjugate, 2 plus 5j. Answer there, answer there. The magnitudes of Z1 and Z2 are, so the magnitude of Z1, it's the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is the square root of 25, which is 5. And the magnitude of Z2, so it's the square root of 2 squared plus minus 5 squared. So it's 4 plus 25, it's 29, so it's the square root of 29. So they might come out as whole numbers, like that one. They might come out as thirds, like that one. I, 1 over Z1, so it's 1 over 3 plus 4j. And what we do, when you've got a complex number at the denominator, you multiply top and bottom by the conjugate, like so. Okay, just put these to one side. So then we need to do 3 plus 4j times 3 minus 4j. So that's 9. That's minus 12j. And that's plus 12j. They are designed to cancel out. And this is minus 16j squared, which is plus 16. So our answer, 1 over Z1, is 3 minus 4j on the top. And then on the bottom, it's going to be, they cancel out, so it's 9 plus 16, which is 25. And there's our answer there. Next one, Z2 divided by Z3. So this is going to be 2 minus 5j divided by 3 plus 4j. So again, we multiply top and bottom by the complex conjugate of the denominator, which basically means change the sign. Okay, so we've already done We've already done 3 plus 4j times 3 minus 4j here, so the answer was 25. So it's going to be 25 on the bottom in the denominator of the answer. Whoops. 25 there, so I need to just do the top now, which is 2 minus 5j, 3 minus 4j, so that's 6, minus 8j, minus 15j, plus 20j squared. J squared is minus 1, so this is minus 20. So the numerator is going to be 6 minus 20, and then plus minus 8 minus 15 in the j's. So it's minus 14 minus 23j. Okay. Now we've got to do this last one. Z1 over Z2. So this is the other way up. 3 plus 4j divided by 2 minus 5j. Tempted to use it's the reciprocal of the previous answer, but I'll do it from scratch. So we multiply top and bottom by 2 plus 5j, which is a complex conjugate of the denominator. So we've got two things to do here. 3, 4j, 2, 5j, so that's 6, 15j, 8j, 20j squared, which is minus 20. So that's the tops multiplied together. Just checking that. I feel like I've done that before. Almost done it before. So that was the numerator. So that's going to be 6 minus 20 plus 8 plus 15j. So it's minus 14 plus 23j. There. And then the denominator is 2 minus 5j, 2 plus 5j, so that's 4, 10j, minus 10j, minus 25j squared, which is plus 25. Sneeze. Sorry. So the answer is 4 plus 25, and the j's actually cancel out, which is what we wanted, which is 29. So our final answer, which I'll write up here, is minus 14 plus 23j. And it's over 29. Straight line, 29. I'll just colour that in. There's the answer that you need for that question there. Okay. Right, 3a. Solve the quadratic equation x squared plus 2x plus 10 equals 0. Hence factorise. Right, so I'll do this with completing the square. So get x squared plus 2x plus 10 is 0. So this is x plus 1 squared minus 1 plus 10 is 0. So we've got x plus 1 squared plus 9 is 0. Let's put some therefores in. So therefore, x plus 1 squared is minus 9. So therefore, x plus 1 is the square root of minus 9, plus or minus. So therefore, x is minus 1 plus or minus the square root of 9 times minus 1. So it's minus 1 plus or minus 3j. So we've got x is minus 1 plus 3j minus 1 minus 3j. So we can factorise as x squared plus 2x plus 10 is equals to x minus 1 plus 3j times, because when you've got the roots, it's always minus the root. It's x minus the root is the factor. So this is x minus 1 minus 3j. So we can simplify this a bit. So it's x plus 1 minus 3j times x plus 1 plus 3j. And that's that one done there. Okay. So what we've used there, what we've used here at this stage here is what's called the factor theorem, which is namely if f of, I'm just going to change this a little bit, if factor theorem with complex numbers. So if a plus bj is a root, i.e. a solution, which is what we've got from completing this square, x minus a plus bj is a factor. And that's what we've used there. Okay, B. So what we have here, for part B, if Z1 is 1 plus j is a root of the cubic equation, determine all the roots. So what we always have is that the roots occur in conjugate pairs. So if Z1 is 1 plus j, we've also got Z2 is 1 minus j. So we already know that x minus 1 plus j and x minus 1 minus 1j is going to be a factor. Oh, these two are factors of the cubic. So we multiply this out. A bit of room here. X 1 plus j, x minus 1 minus j. So that's x squared. This is minus x times 1 plus j. This is minus x times 1 minus j. And then in this corner here we get 1 minus j times 1 plus j, because the two negatives cancel out. So when we multiply these together, we're going to get x squared and then minus x times 1 minus j plus 1 plus j. They've come from, that's the minus x is come outside the bracket there. It's 1 minus j there, 1 plus j there. And then this is going to be 1 minus j times 1 plus j, which is going to be 1 minus j plus j minus j squared. So what I've done there is 1 times 1 is 1, minus j times 1 is minus j. So I've done both of these times 1, then I'm going to do both of these times j. 1 times j is j, and minus j times j is minus j squared. So this is x squared, they cancel, minus 2x, they cancel, and minus j squared is plus 1, because j squared is minus 1. So that's going to be plus 2. Okay, so we now know that x cubed minus 3x squared plus 4x minus 2 is x squared minus 2x plus 2 times a linear factor x plus a, say. Okay, so let's figure out what it must be. We know it's x squared minus 2x plus 2. We know there must be an x there to get x cubed. Okay. So we've got minus 2x squared when we multiply this x by this 2x. And we actually want minus 3. We actually want minus 3x squared. Our other x squareds are going to be in there. So if we put a minus 1 there, we'll get minus x squared. Then we've got minus x squared minus 2x squared does equal minus 3x squared. So now this should work for everything. So here, in this here, it's minus 1 times minus 2x. So that's going to be plus 2x. And then we've got 2x there as well, because there, that's x times 2, so that's 2x as well. And then 2x plus 2x is 4x, and there's minus 2, which is what we wanted. So we end up with x cubed minus 3x squared plus 4x minus 2. So it's x squared minus 2x plus 2 times x minus 1. So the roots of x cubed minus 3x squared plus 4x minus 2 equals 0 are z1, which is 1 plus j, z2, 1 minus j, and that comes from the complex conjugate, and the third one comes from here, which means when x minus 1 is 0, so it means x equals 1. Okay, I'm just thinking about the notation, but I'm quite happy with it as it is. X is, Z's are usually reserved for complex numbers. But you could call this x1, x2 and x3, I don't mind. Right, C. If Z1 is 1 minus j is one root of the fourth order equation, there, determine all the roots. So we've got Z1 is 1 minus j. So the second one, Z2, is 1 plus j. Okay, and we already know that x minus Z1 times x, that should be an x minus Z2, and that is, we did that on the previous page, 1 plus j, look there, we've got x minus Z1 times x minus Z2 is x squared minus 2x plus 2. So I'm just going to carry that over from here, x squared, so just check that, x squared minus 2x plus 2. Okay, so then we know, right, so we've got x squared minus 2x plus 2 multiplied by something down here. Don't quite like this, it's going to get messy. Multiplied by x squared, and then we've got so many x's and then a constant. So basically we've got this, which is there, times this has to make that. Okay, so that is x to the power 4. We've got that one. Then we think about our x cubes. So this isn't minus 2x cubed in this box here. The other place where we get x cubes are here, because this is x times x squared is x cubed. And we need minus 2x cubed. And we've already got minus 2x cubed. So therefore, a is 0. Okay, so that means we've got, that's a 0, that's a 0, and that's a 0. We've got our minus 2x cubed. Brilliant, that's a real good start, which is what I wanted. Right, so next thing we need to think about the x squared. So we want minus 2x squared, and there we've got plus 2x squared. We need minus 2. So we haven't got any x squareds in this middle row because of all these zeros. So the other place that we get x squareds is there. We've got 2, we want minus 2. So we've got to take away 4x squared. So b is 4. Okay. So that's sorted that one out. So then we want 8 x's. We can't get any x squareds from this, any x's from this row because they're all at least x squared because of that there. So we can't get any from there because a is naught. So the only place we can get x's is there, where it's b times minus 2x. And b times minus 2x. Sorry, b is minus 4. b is minus 4, that's better. b is minus 4. So then minus 4 times minus 2x is 8x. Good. And then the last one, minus 4 times 2 is minus 8. Good. Okay, so we've got x to the 4 minus 2x cubed minus 2x squared plus 8x minus 8 is x squared minus 2x plus 2 times x squared minus 4. Okay, so the roots, we already know for this first one here, the roots are z1, which is 1 minus j, and z2, which is 1 plus j. And then we've also got where x squared minus 4 is 0, so x squared is 4, so x is plus or minus the square root of 4, x is plus or minus 2, x is 2, x is minus 2. And there's our answers there for that one. Right, number 4. If z1 is 1 plus 3j, z2 is 2 plus j, determine the complex numbers z1, z2. Let's do that first of all. So we've got 1, 3j, 2 and j, so that's 2, j, 6j, 3j squared, which is minus 3. So z1 times z2, 2 minus 3 is minus 1, 6j plus j is 7j. Okay, so I've done that part there. Plot all three numbers on a complex plane. Determine the modulus r and principal value of the argument of each of the complex numbers. So let's get this now drawn here. Straight lines, good. So here's the real, here's the imaginary. Okay, so z1 is 1 plus 3j, 1, 2, 3. So that's z1. z2 is 2 plus 1j, which is about there. And z1 times z2 is minus 1 plus 7j, which is about up there. Z1 times z2 is roughly there. Minus 1. That's not very neat. What's happened there? Come back. Right. Not sure if I like that. Oh, it'll do. 7 is fine. It's not bad. Right, let's get this right. Minus 1 is too far there for my liking. Right, let's start again with that bit. Right, so that was 1, 2. So minus 1 is about there. That's 3. That's 7 up there. There we are. Straight line from there to there. Nope. Well, it doesn't want to draw that there. Let's do that there. Let's try again. Straight line from there to there. That'll do. Okay, there. And that is z1 times z2 there. Okay, so plot all numbers on the complex plane. Done. Determine the r, modulus r and principal value of the argument of each of these complex numbers. So r of z1, so it's the square root of 1 squared plus 3 squared. Okay, so that's from there 1 squared plus 3 squared, because that's Z1. So it's 1 plus 9, which is 10, so it's root 10. The R for the second one is the square root of 2 squared plus 1 squared, square root of 5. And the R with the third one, which is Z1 times Z2, so it's the square root of minus 1 squared plus 7 squared, which is the square root of 50. So we've got a set of answers there. And then we want the theta for each one. Let's just call this, I've just called that one Z3. Okay, so it matches the notation there. So the theta for the first one is tan inverse Z1 3 over 1. You do the imaginary divided by the real. Okay, so that's calculator and use radians. Shift setup for shift tan inverse 3 over 1, which is 3, so 1.25. Okay, theta 2 is going to be tan inverse, and that's going to be 1 over 2. So tan inverse 0.5 is 0.46 radians. And the third one, now the third one, it will come up when you do tan inverse of, just type my nib there, when you do tan inverse of the imaginary over the real, 7 over minus 1. So it's tan inverse of minus 7. Your calculator actually gives the answer. I'll just show you this here. I'll just write this down. It gives the answer as minus 1.43. So your calculator is giving you the angle down here. And whenever the real part is negative, it's going to give you, you want the complex number is going to be located in there or in there when you've got a negative real part. But your calculator gives you an answer in there or in there. And so what you've got to do is add pi on to get it into the right place. So we've got, so theta 3 is going to be minus 1.43 plus pi. So if the real part is negative, add pi. So it's 1.71 radians, so that it goes into the right place. Okay, because we measure that on that there, that's 1.71. That's pi, which is 3.1. Okay, so we want it to be between 0 and 3.14 pi. So our answers here are that one, and that one. Okay. Number 5. Determining the modulus R and the argument of each of the following. Okay, I'll do that first of all. So R is the square root of 4 squared plus 3 squared, which is actually 5 on your calculator. Theta is tan inverse 3 over 4, which is 0.64. Okay, this one, R is the square root of 2 squared plus 2 squared, which is the square root of 8. Theta is tan inverse 2 over 2. Tan inverse of 1, which I know off by heart, is pi by 4. This one, the R is the square root of 1 squared plus minus 1 squared, so it's the square root of 2. Theta is tan inverse minus 1 over 1, which is minus pi by 4. And this one, the R is the square root of 1 over root 2 squared plus 1 over root 2 squared. 1 over root 2 squared is a half. A half plus a half is 1, so it's the square root of 1, which is 1. And theta, tan inverse 1 over root 2 divided by 1 over root 2, which is plus pi by 4. Okay, so I've done that down the side there. Hence express each in both polar forms and complex exponential form. Okay, so 4 plus 3j is going to be r 5 cos 0.64 plus j sine 0.64. We can say that's 5e to the 0.64j. I'm just wondering whether, actually I'm just going to expand this a little bit more. Shift, I'm going back to, I'm just going to do this, but to get this as an exact answer from over here, then do 5 times cos of that, plus 5 times j sine of that. So what tan inverse of 0.75, and that's answer. 5 times cos, answer. No, it's just bringing me back to 4 plus 3j. What on earth was I thinking? Of course it does, yeah. So I'm just going to leave it like that. And we can say it's also 5e to the 0.64j. Okay, so the answers, that's the r, that's the theta, that's one form, that's the other. Okay, so the second one, say 2 plus 2j is root 8 cos pi by 4 plus j sine pi by 4. So that's root 8 e to the pi by 4j. Highlighter there, 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 and there. C, 1 minus j root 2 cos of minus pi by 4 plus j sine of minus pi by 4. Now actually we can do something with this one, because cos of minus pi by 4 is the same as cos of plus pi by 4. And this one, you take a minus outside the bracket, sine pi by 4, like so. And we can also say it's root 2 e to the minus pi by 4j. So I didn't, that's one answer, that's also another answer there. But I use this, I use the minus pi by 4 there, because that's the best way to do that. So this one, 1 over root 2 plus 1 over root 2j is r, which is 1 cos pi by 4 plus j sine pi by 4. So I don't need that 1. So we can just leave that like that. We can also say that is actually 1, which we don't need to write, 1 e to the pi by 4j. There, 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 and there. There's an answer, there's an answer. Okay, number 6. What have I done? Not written down the question. Let's find the question. Number 6. Gosh, I'm getting tired. I've been doing loads of this today, not just yours. But I'll keep going. We'll have a break after this one. Question 6 for the 3, 4, 5, 6. I didn't write down the questions. Right, A. It's 3e to the j pi by 3. So this is going to be 3 cos pi by 3 plus j sine pi by 3. Pi by 3, that's one that I should know. And I do know it. It's 3. Cos of pi by 3 is a half. Sine of pi by 3 is root 3 over 2. So it's 3 over 2 plus j times 3 root 3 over 2. That's your answer for A. B, 2e to the minus j pi by 4 minus j pi by 4. So it's 2 cos of minus pi by 4 plus j sine of minus pi by 4. Cos of minus pi by 4 is 1 over root 2. And sine of minus pi by 4 is minus 1 over root 2. So this is going to be 2 over root 2 minus 2j over root 2. Actually, 2 over root 2 is root 2 minus root 2j. Do all that on your calculator. C is 2e to the j. So it's 2 cos 1 plus j sine 1. So calculator in radians, 2 cos of 1, which is, for the first one, so it's 1.08, and then it's 2 times the sine of 1, 1.68, plus j times 1.68. So right, there's 1.08 plus 1.68j, both to 2 decimal places. And then D is, where's D? 4e to the j pi by 2. So it's 4 cos pi by 2 plus j sine pi by 2. Cos of pi by 2 is 0. Sine of pi by 2 is 1. So this answer is just 4j, like so. Number 7. Z cubed is minus 1. So the way to do these, think here, minus 1 is here. Okay. Minus 1 is equals to 1 e to the j pi, because the angle is pi radians and its length 1 from the origin. So we drop the minus sign there. And then we can also say it's multiples of 2n pi, because if we go around, look, go around once, there's 1 pi, and then go around 1 pi, and then another 2 pi, and then another 2 pi. This means we always end up back at minus 1. So we've got z cubed is e to the j pi plus 2n pi j. So it's e to the j pi 1 plus 2n. That's factorising, taking a j pi outside the bracket. And we've got n is 0, 1, 2. So z is the cube root of this, so it's e to the j pi. The cube root of z cubed is z. The cube root of this thing, we say it's 1 plus 2n, we divide by 3, the cube root there. So we say n is 0, z is e to the j pi, and then if n is 0, that's 1 there, divided by 3. What form do we want it? I'll write it in the other form. So it's cos pi by 3 plus j sine pi by 3. Cos of pi by 3 is a half plus root 3 over 2j. That's the first root there. N equals 1. We get z is equals to e to the j pi. And if n is equals to 1, so 1 plus 2 times 1, that's 3. 1 plus, so we get that, and we've got to divide by 3. So it's e to the j pi 3 divided by 3, which is e to the j pi. So this is going to be cos pi plus j sine pi. Cos of pi is minus 1. Sine pi is 0. Call that Z0. Call that Z1. And finally, n is 2. So the third one actually. It's going to be e to the j pi. And then it's times 5 there. Times 5 over 3. Because if n is 2 in here, 1 plus 2 times 2 is 5. And this is going to be cos 5 pi by 3 plus j sine 5 pi by 3. Cos 5 pi by 3. Calculator, that one is a half. And then sine of the same thing is minus. Oh, go away. Come back. I wanted the... Get back. There we go. Minus j times root 3 over 2. And there's all 3 roots. Okay. Number 8. Z4 is 18. Sorry, Z4 is 16. So if Z4 is 16, Z squared is going to be plus or minus the square root of 16. Because if we take the square root of each side, the square root of Z to the 4 is Z squared. And then the square root of Z of 16, plus or minus root 16. So therefore, Z squared is 4 or minus 4. So we take if we've got Z squared is 4, Z is going to be 2, or Z is minus 2. If we've got Z squared is minus 4, Z is plus or minus the square root of minus 4. So it's plus or minus the square root of 4 times minus 1. So it's plus or minus 2j. So if Z to the 4 is 16, Z is 2, minus 2, 2j, minus 2j. Number 9, evaluate 1 minus j to the power 20. Let's just get that one ready there. Won't be a second. 1 minus j to the power 20. I am really tired. There we are. Right, so what we do here, the best way to do this, if we've got, oops, get that back. If we've got z is 1 minus j, which is down there. We've got r is the square root of 1 squared plus minus 1 squared, which is root 2. Theta, tan inverse, opposite, over adjacent, minus pi by 4. Okay, so z 1 minus j is root 2 e to the minus pi by 4j. Okay, so 1 minus j to the power 20 is the same as root 2 e to the minus pi by 4j to the power 20. So this is 2 to the half e to the minus pi by 4j to the power 20. This is 2 to the half to the power 20 times e to the minus pi by 4j to the power 20. And when we've got these brackets with these powers, we multiply across the bracket like so. So this is 2 to the half times 20 times e to the minus 20 times pi divided by 4j. So it's 2 to the power 10 times e, and then this, oops, didn't mean to do that. That 4 cancels, let's make a 5, minus 5 pi j. Okay. 2 to the power 10 is 1024. And then this is going to be cos of minus 5 pi plus j sine of minus 5 pi. Right, cos of minus 5 pi, let's think where that is. Minus 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So minus 5 pi is there. Minus 1. So this is equals to 1024 times minus 1. And the sine of that is 0 plus j times nothing times 1024, but we didn't really need to put that in. So our final answer is that minus 1024. Tip of the tongue. Number 10. Express each of the following in standard form. Sorry, that wasn't the tip of the tongue, I was just surprised. That was a sign. Because you start with 1 minus j to the power 20, and with minus 1024. Yes, anyway. 10a, 2 to the 2j. Right, what we do here is say 2 is e to the log 2. Because e and log are inverse functions, so that's 2. So this is 2 to the 2j, e to the log 2 to the power 2j. So it's e to the 2 log 2 I'm just trying to think where to put the j, where it will look the best. Let's put it e to the j times that. Okay, so basically I've put this 2j in the front there, 2j. Okay, so this is cos 2 log 2 plus j sine 2 log 2. And you can take that one stage further on your calculator if you so wish, then you will get, I've got the answers in front of me, so assuming these are right, 0.184 plus 0.983j. Okay, I'll just check that one. Cos of 2 log 2, or ln 4. Yes, I'll make it. I think there's been some rounding errors on the one that I've just used, so I'm going to have to do it properly. It's 0.183, and then sine of ln 4 j times 0.983. Okay, next one, b, sine of pi plus j. Right, for this one, you're going to use sine a plus b, sine a cos b plus cos a sine b. Okay, so this is going to be sine pi cos j plus cos pi sine j. Sine of pi is 0, so it's going to all be 0. Cos of pi is minus 1, so it's minus sine j. Okay. And then you have sine j is j hyperbolic sine of 1. So this is going to be minus, because we've got minus sign there, minus j hyperbolic sine of 1. Okay, and that is going to be minus 1.175j. Okay, So basically there, the rule that we've used, that sine j is j hyperbolic sine of 1. That's the rule that we've used there. This one, so this rule we're going to use cos A plus B, cos A, cos B minus sine A, sine B. So this is going to be cos pi by 2 cos minus 2j minus sine pi by 2 sine minus 2j. Cos of pi by 2 is 0. Sine of pi by 2 is 1. So it's going to be minus 1 sine of minus 2j. And what we do here is sine of minus 2j is minus, just remembering this one, minus j hyperbolic sine of 2. That's what we use here. So this is going to be sine of, it's going to be j hyperbolic sine of 2. When we do that on your calculators, it's going to be it's going to be, so I'm a bit slow with this. I don't think this is in the syllabus this year. So I'm just talking you through anyway, so don't worry too much about question 10. I'll do them anyway. Especially not those sine and cosine ones. Don't worry too much. I think we need to, when they come up again, I'll go back over that one. Right, with this one, if we say log of root 2 plus j root 2, that's going to be a plus b j, like so. So what we can say is root 2 plus j root 2, e to the a plus, so e to the a plus bj. Okay, now root 2 plus j root 2, root 2 plus j root 2, the r is root 2 squared plus root 2 squared square rooted, which is the square root of 2 plus 2. So it's the square root of 4, which is 2. And the theta is tan inverse root 2 over root 2, which is tan inverse 1, which is pi by 4. So we have, on the left-hand side, it's going to be r e to the j theta. So we're going to have 2 e to the pi by 4 j is e to the a plus b j. Okay, now the 2 here, the 2 is e to the ln of 2. Okay, so we've got e to the ln of 2 times e to the pi by 4j is e to the a plus bj. So e to the ln 2 plus pi by 4j is e to the a plus bj. So a is ln 2 and b is pi by 4. So therefore ln of root 2 plus j root 2 is ln of 2 plus pi by 4j. Okay, that's that one. E, j to the 2j. Okay, right, so what we do here, j raised to the power 2j. So we think about j is here. That's 1j on the imaginary axis. This is pi by 2. So j is 1 e to the pi by 2j. E to the pi by 2j. So we've got e to the pi by 2j raised to the power 2j, which is e. So the 2's will cancel, and it's going to be e to the, and it's j squared, which is minus 1, so it's e to the minus pi. Okay. E to the minus pi. What can we do with that? We could just leave it like that. Have a little think to see if there's anything I can do with the answers. E to the minus pi. Just looking at this answer here. There's nothing wrong with that, but we could do a little bit. If we want it as a complex number, I'm just going to look at the answer and use their answers. So we've got this is an or. So it's j to the 2j is 1 e to the j pi by 2, which is what we had here, raised to the power 2j. So it's 1 to the power 2j times e to the minus pi, which is, well, e to the minus pi is what we had there. But I've just done the 1 to the 2j and I've included that in this time round. 1 is e to the ln 1 to the power 2j times e to the minus pi. So this is e to the ln 1. Ln of 1 is 0. So it's e to the 0 to the power 2j times e to the minus pi. So it's e to the 0 times e to the minus pi. And I've come up with the same answer. Oh, so then they've just done e to the minus, e to the minus pi on the calculator. E to the minus pi. Right, so it's 0.0432 plus nothing in the j's, and there's your answer. Yeah, overdone. I got that there, straight out. E to the minus pi. So at that stage there, I could have said that was 0.0432. I think I'm getting tired. I'm still getting tired. They just put the plus 0j on as well. Right, and the last one. 2 plus 2j to the 1 minus 2j. Right, this is the one that you quite often need for your exams. So you'll see this one in the past exam papers. So we get 2 plus 2j. Something like this, where that's 2. And that's 2. R for 2 plus 2j is the square root of 2 squared plus 2 squared, so it's the square root of 8. Beta, tan inverse 2 over 2, which is pi by 4. Okay, so we've got root 8, e to the pi by 4, j to the 1 minus j. So this is e to the ln root 8 times e to the pi by 4 j 1 minus j. So this is e, so we're going to do each one to the power 1, and then each of these to the power 1, then each of these to the power minus j. So root 8, so to the power 1, leaves them unchanged, and then it's times e to the j ln root 8 times e to the minus j squared, so it's going to be plus pi by 4. equals, so it's e to the pi by 4 plus ln root 8, which is that one plus that one, times e to the j pi by 4 plus ln root 8. So it's e to the pi by 4 plus ln root 8. So it's cos pi by 4 plus ln root 8 plus j sine pi by 4 plus ln root 8. Double bracket there. Okay, so I'm going to get this in the calculator. E to the pi divided by 4 plus ln root 8 is what I've typed in there. E to the, I need to use the fractions button on this calculator. No, I don't, yeah, pi by 4 plus ln root 8, and close the bracket. I don't think I did before. On the outside, 6.2035327, etc., etc. Okay, so there I want cos pi by 4 there, that's minus 0.2515, etc., etc., plus j sine of that times 0.967833, etc., etc. So I'll just type in the numbers that I've got. 6.2035327 times minus 0.2515. So this one, I've got this as minus 1.56 there, plus 6.23537 times 0.967833 plus 6j. Okay, and I think that completes the questions. Well, that last one was a long one. Okay, well done for getting to the end.